Now, the next method is automatic repeat request is the method for checking in terms of packets. Now, we understand what packets are and what packet switching network does. And our bulk of internet transmission is handled through packet switching. And therefore, there is a huge need for automatic repeat requests to ensure that all packets are transmitted correctly. Now, the basic principle of your ARQ is that my sender and receiver are relying on the process of sending packets and a process of acknowledgements to make sure that each packet that is received is known to the sender. Now, this method over here, this is one method. This is known as a stop and wait technique. This is one example of ARQ. There are multiple example types of ARQs, but this is the most basic type of ARQ, which is known as the stop and repeat ARQ. Now, what happens is that my sender will send a packet, and after sending a packet, my sender will wait a certain amount of time for acknowledgement from my receiver. Now, as you can see here, I sent a packet to my receiver. Upon receiving the packet one, my receiver will send an acknowledgement. Okay, because my sender has received an acknowledgement from my receiver, that means my sender is convinced that packet one has reached the receiver. In which case, upon receiving this acknowledgement, my sender will proceed on sending packet two. As you can see here, packet two did not end up at the receiver. It was lost here. There is packet loss in between here, and that packet did not manage to reach my receiver. In which case, if my packet two did not end up at the receiver, that means obviously there will be no acknowledgement sent from the receiver. My sender will wait a predefined amount of time. This is known as a timeout period. And after this timeout period, since it did not receive an acknowledgement, it means my sender will assume that the packet was not received by the receiver, in which case it will send packet 2 again. This time around, packet 2 reached my receiver, and then the receiver will properly replied with an acknowledgement. And now I'm satisfied that packet 1 after packet 2 has been also sent to the receiver. Let's take a look at what happens with packet 3. Packet 3 reaches my destination, my receiver, but the acknowledgement does not manage to make it back with me. In this case, yet I will wait a certain amount, that fixed amount of time in my timeout period for that acknowledgement for packet 3. But since I did not receive the acknowledgement from packet 3, my sender will assume that the packet did not make it to the receiver, even though it did. But since I did not receive the acknowledgement, my way of determining whether or not you received the packet is through acknowledgements. Now, I did not receive the acknowledgement for packet 3, in which case my sender will assume that packet 3 did not make it to the receiver, and it will resend packet 3 again. So this is a very basic method of ARQ. Now, it is again slow because I am relying on the acknowledgement for each packet, and there is a great chance that I will have to retransmit packets that I have already previously sent because the acknowledgement did not reach me. For example, you see here packet 3 was sent. The acknowledgement did not come back, and I assume that packet 3 did not make it to you, and I will resend packet 3. So this is stop and wait technique is slightly, in this case, lagging. However, there's another method that is known as selective repeat. Now, selective repeat, there is another method as well, but selective repeat is the most, simpler method. Selective repeat means that I have a sender here and my receiver here. Now, instead of, say, for example, each packet and sending an acknowledgements, what we do is that we rely on negative acknowledgements. Now, what happens is that imagine that I've sent packet 1, then I send packet 2. Notice that packet 1 is received, packet 2 is received, in which case now let's just say that packet 3 is lost. But packet 4, remember that we have sequence numbers maintained in packets. This is where it becomes important. I sent packet 1, packet 2, packet 3 was lost, but packet 4 reached here. My receiver will say, okay, I got 1, I got 2, where is 3? 3 is missing because I got 4. I did not get 3 in between. I got 2 and I got 4, but 3 is missing. So after this situation, my receiver will say, okay, one is packet is missing in the sequence. Packet 1 got me, packet 2 got me, but the next packet that I received was packet 4. That means packet 3 is lost somewhere. In which case, and it is possible that time, during this time, I managed to send packet 5 as well. Now imagine that my receiver will say that, okay, packet 1 I got, packet 2 I got, packet 3, packet 4 I got, I even got packet 5, but packet 3 is missing. In which case my receiver will send a negative acknowledgement. This is known as a negative acknowledgement. It's simply as a previous method, which is only relying on acknowledgements when a packet is received. But negative acknowledgement means that I'm simply telling you that the packet that I did not receive, and specifically the packet that I did not receive. So negative acknowledgement 3 means that my receiver is telling my sender that I got 1, I got 2, I got 4, but I did not get 3. So please resend 3, in which case my sender, after receiving the negative acknowledgement for packet 3 from the receiver, I will send packet 3, and hopefully this time you will get it. And since packet 3 is received by the receiver, and you can see here that 4 and 5 has also been received by the receiver, I don't have to go back to 4 and 5 again. I can simply proceed on sending 6, because 4 and 5 have already been sent. Now, this is where, even though my 6 comes after 3 and 4 or 5 came before 3, and sequence seems all mixed up, but that doesn't matter, because this is why sequence of packets, sequence number in packet header is important. My receiver can rearrange packets according to the sequence number, making the data complete in its original form. But this is a very faster method because it does not rely on the process of acknowledgement against each packet. It only sends a negative acknowledgement when it does not receive a packet, as you can see over this method. So this is a very good, very faster method, but still it ensures that each and every packet is received.